us to all sorts of trouble, you can at least figure out what's going on and do something about it. So using shared memory, the kernel developers kind of see this as an antiquated thing that people do that they shouldn't do anymore. The newer replacements for it, though, just don't have the same safety features that Postgres would really like. If you've been dealing with Linux for any period of time, you probably know that safety concerns are not necessarily the top priority in Linux kernel development. So the thing to realize is that the default parameters on this stuff, in Linux, for example, only let you allocate 32 megabytes of shared memory by default. That's it. So Postgres will look at what it can do at the beginning, and while we would like the default configuration to use more memory than that, it can't until you fix this kernel root problem first. So if you look at the rule of guidelines for, well, what would the default configuration be appropriate for, if you reverse it back out, the default configuration is completely sensible and you should not worry about it at all and deploy it like that if your server has 256 megabytes of RAM. Last time I checked, my phone had more RAM than that, so it's probably less powerful than this server. You do need to adjust a number of memory-oriented parameters to work around this, and if you assume the default configuration is correct, it's another one of those things where when you pose problems to the mailing list and say, hey, how come my performance is terrible on this? People say, well, you're using the default configuration, and the default configuration is terrible, followed by a round of people saying, what the hell are you doing? Shipping a default configuration that's terrible, followed by a round of finger pointing at the kernel developers again, and the cycle is better just to build a lesson. Just go through it. The link that you can't read here probably is to a good article that myself and some other Postgres contributors have worked on. It's called Tuning Your PostgreSQL Server. It's over on the wiki.
So it's never really occurred to me before, but for those packages that are coming from distributions, why don't they just include as part of the installation process?
That's an excellent question. I would love Red Hat to be receptive to ideas like let's go change the shared memory things to be huge by default. Unfortunately, I think they see this as a security issue that individual clients, if you let them allocate large amounts of shared memory, there's a potential for something resembling a denial of service attack where people can do scary things with shared memory and leave the things behind and that sort of thing.
So not even for like interactive, depending on the settings and install stuff, you can do much more familiar with that. Sometimes they're actually very things like also versus loading questions.
Yeah.
Actually, so you load more data.
Yeah. Right, it's a great idea. I mean, the first step to that is we probably should come up with the tool that does what you just described for us. That's something that I've been working on. So we have a Google summer code student this year who is interested in working on stuff in this area. So we'll see if I can get him to actually do some of the stuff that you need to get around to. This area would actually be something that I think would be some progress on. At this point, the current level of automation is I have a script that I give out when people complain that this is too hard, that if you run it on a Linux system, it spits out values, and you just put them in your kernel configuration, and you're done. To try to avoid it. So the Tuning Your PostgreSQL Server article goes over 15 or so of the common parameters that you really want to consider changing in your Postgres server. And some that people tend to really get excited about and assume that they do things that they don't, so kind of clarify what is it that this does and doesn't do. There's also a utility that I've written, it's just a little rough yet called pgtune. What pgtune does is worry about, it looks at two things. It looks at how much memory is in the server, and if you're running it on a server other than the production one, you can say, well, the server I actually am running this on is this much RAM. They don't necessarily have to be the same. And then it also takes as an input a concept of workload. Common database workloads are, I've got a data warehouse, there's online transaction processing or OLTP, stuff that's kind of optimized for writing lots of smaller things, but not necessarily running giant queries. And then there's web application, which tends to be a little bit different than any of those other two. So PGTune takes how much memory do I have and what type of workload am I expecting, and spits out a reasonable starting configuration. So if you just really want to be hands-off with this, run PGTune, and it'll at least it'll get you the kind of things that we wish we could put in as the defaults, but unfortunately can't because of these kernel things. It does not intend to yet be a really comprehensive tuning tool for Postgres, but it's a decent start. So what are the major parameters that you definitely want to take a look at? The first one's called shared buffers. Shared buffers is how much memory is dedicated to Postgres for what it calls a Postgres buffer cache, the same sort of concept exists in most databases. A lot of people who have been DBAs with other databases think, well, I'm going to give Postgres most of the memory on the server because it's a database server. That tends not to work out so well for a couple of reasons. One is Postgres uses the operating system cache when it reads and writes things. So it expects that that is there, and if you try to tune Postgres to be more like a traditional database server, if you say, well, I'm going to give it all the memory in the server, and I'm going to switch it over to use direct.io and all these other things, it's not going to work out so well. There are going to be things that you didn't expect that are going to get dramatically slower as a result of those changes. The old guideline for shared buffers, we used to tell people, set it to about a fourth of the amount of RAM in the server. It's increasingly becoming not such a useful guideline because due to some architectural limitations within Postgres that we haven't even really completely mapped out the reasons behind yet, shared buffers tops out at around 8 gigabytes. If you set it to bigger numbers than that, what you discover is performance starts to fall off, and you'd be better off letting the operating system manage that chunk of memory. There's a second issue in here, which I have a whole talk devoted about in the main conference section called the right stuff. Periodically, Postgres runs through checkpoints, and checkpoints write all of this data, however big you set shared buffers to. It has to do a reconciliation of all that data with disk, and how complicated that reconciliation is proportional to how big this number is. If you set this thing to, oh, I've got a 64 gigabyte server, I used to read 25%, makes sense. Okay, let's set shared buffers to 16 gigabytes. You're not going to be happy with what happens if you ever do manage to get 16 gigabytes worth of data that needs to be hidden in one checkpoint. It's not going to be good. So the normal effective range for this, the default is going to be around 32 megabytes. There's a significant gain in almost every case going from that to 512 megabytes. Now, some sites stop there for two reasons. One is this checkpoint problem that I just mentioned. Usually around 512 megabytes is when it becomes easier to run into a checkpoint problem. The reason for that is just minutia around how big caches and RAID controllers and other bits of hardware. The other one is if you're running on Windows, we've gotten lots of reports that once you get above 512, it just stops doing anything useful. So we know on Linux and Solaris and some of the other popular platforms, you get useful benefits all the way up to 8 gigabytes. If you're on Windows, it probably tops out at 512. Just one of those quirks of how Postgres on Windows works. The exact reason behind it is not really very well recognized. So this is kind of the range you should be aiming for. If you aim on the low side, that's okay. As long as it's not at the default of 32, you get the majority of the benefit. You know, it's like a lot of things, you probably get 75, 80% of the benefit just going from 32 to 512. You know, if you want that extra little bit, consider going up to the multi-gigabyte range. Don't go too crazy with it though, and do watch out for checkpoints, which I'll talk about a little bit later. next thing to recognize is that how often checkpoints happen is on a